Hello and welcome everyone this morning. Thanks for joining us today. My name is Damien and I work closely with our manufacturer partners, and I will be in the background moderating this week's guest webinar. I've said this before and I will happily speak to it again. We love these guest webinars because it provides an additional platform of communication and learning for both the designer and the manufacturer. So we always like to emphasize the importance and educational value of these. This week we have Shelly Walker from GPH Irrigation, and she's going to talk to us about what to consider when implementing drip irrigation to your projects. I know Shelly has an intro slide or two, so I'm not going to repeat anything that she's going to touch on, but overall, it's going to be a great presentation starting from a broad view on drip irrigation and then heading down into the nitty-gritty details where I'm sure there'll be plenty of questions. So speaking of questions, let's just go through our quick Q&A reminders. If you have any questions throughout the webinar, please type them into the Q&A window, which can be accessed by clicking on the Q&A button on your screen. Some questions may be answered directly by me. Otherwise, we will have a moment to answer questions at a point during the presentation, and of course, right at the very end, where we'll get Shelly to answer those live for you. From this point though, I'd like to hand over to Shelly to introduce herself a little and get us underway. Thanks, Shelly.
Thank you, Damien. You can hear me, correct?
I can, yes.
Okay, good. Hi, everyone. First of all, thank you, Damien, for the introduction, and thank you for having me. I'm so honored to present this webinar and to be affiliated with Land Effects since 2010, I believe. So it's been a little while, and Land Effects is amazing, as you all know, and they're a great company to partner with. Just a little bit of background of who I am. I am the co-owner of GPH Irrigation, and I've been in this industry for about 20 years. And I did get my Bachelor's of Science in Cal Poly Pomona in agribusiness. I speak at UNLV, different ASLA events, and I'm also have been an editor for many articles and guides. In regards to GPH, the company that I co-own, we are proud to say that we are environmentally responsible, and we reuse 99.5% of all our products and material, so keeping that waste out of the landfills, which is very important to us. And we are proud to say that we are the first manufacturer to utilize the bio-based plasticizers. We manufacture product primarily for commercial, some agriculture, and also retail. So I'm going to try to cover all those bases a little bit today during my presentation. And here's an overview of what I'm going to talk about. I'm not going to go over this overview now, but if you'd like to look back, this is a good place to check to see the slides of interest. The first thing I like to talk about, obviously, is water. That is why drip irrigation is used. Drip irrigation is known to conserve water. And just to go over a little bit of facts, according to the Census Bureau, unfortunately, the US population is growing 3.3 million a year, which is quite a bit and a scary number, to be honest. So I'm sorry to share that with all of you. But on that note, we have to keep in mind that as users, we're using about 100 to 175 gallons of water per day. And that's about 63,875 gallons a year, which is just sounds like a lot of water. So we can always use drip to help conserve. We all need water to survive. We all need plants to survive, so we have to conserve. And according to the EPA, the drip irrigation can save 30,000 gallons of water per year. So that's about 3 times of what the average landscape consumes. So that's quite a bit of water. Just a quick definition of what drip is. Drip is a concentration of the plant's root zone. So it's providing water to the roots of the plant. And you can see in this diagram here, this is the perfect wetting pattern, but that's the base of it. It's very efficient, and it's concentrating on the roots, and that's what we need to do with plants. a quick history of drip and kind of something that I wasn't aware of, kind of interesting. Going back to 100 BC, ancient China, they used these porous, unglazed pots. And how these work is the water was poured up top here, and then the water percolates out to the roots. And so the water was stored, and then over time, the water basically infiltrated through the pot and watered the plant that way. This is a very primitive way to, I guess, call what is drip irrigation, but this was the first. The second was this porous pipe, which is the same idea, but now we're putting it in a pipe system. And then after that, in the 1920s, the Germans invented a perforated pipe, similar, but with perforations. The big change happened in the 50s when we started extrusion and molding of plastics. And you can see here, this is an extruder. This pushes out a lot of plastic, and then at the end here, it's producing the pipe. You can see up close. Different sizes and different lengths are extruded on machines such as this. This is an older extruder. This is just a historical picture. But this changed everything because now we're working with plastics. And it just made a lot of things more easy and easier to produce in regards to clay. The next thing in the 60s, farmers began to use drip on their irrigation crops. And you can see here, this is inline tubing irrigating crops and the plastic tubing being used. So that changed things immensely versus flood irrigation and other things, and it made crop production so much more efficient. In the 80s, we actually introduced it to commercial landscape, and that was more of a point source type where we had a lot of spaghetti tubing and different things. And that kind of, it was great and it was a good use, and people were trying to use drip, but it wasn't to its potential. And I think it was a little bit high maintenance at the time. And so there was a pushback, maybe not a lot of education. There was a pushback to the 90s where it went more towards spray and overspray and such. But then in the 2000s, technology kept improving on drip because we kept using it for agriculture. And then there was a resurgence, a lot to do with water shortages. It was more efficient, technologies had been improved, and there was more education. So just to go over some of the typical drip system components. This is based off a commercial system. On the left here, you can see a backflow preventer. This is to prevent any debris or contamination from going back upstream. And it's very important because we wouldn't want that going into our plumbing. On the right, you have the controller. This item here actually can be programmed with different zones, and I'll get into zones a little bit later. But you can program in when your system turns on, how long it's going to run, and different things of such. You can actually, the technology is there now where you can control it from your phone and turn that actual controller on now. There's algorithms built into this to predict the ET and that area and climate. So controllers are amazing. What the controller does is then communicate to this valve here. This valve is what turns the system on and off. So this is the valve that I will refer to later. So this opens and closes and allows the water to pass through. And then on any drip irrigation, the typical system needs to run between, I'm going to say on average, 10 to 50 PSI. So when using drip, it's a necessity to have a reducer depending on the pressure. And this is a pressure regulator here. So on an all drip system, you will find a pressure regulator. Also with drip, there's small orifices and small emitters and small devices. So you need to filter the water. And this is what's called a filter here. So that keeps any sand or any elements or anything from getting in the lines. And I also would suggest maintaining this filter, at least with a basic general, at least 2 times a year. And you can do that by unthreading this filter here and then cleaning the filter out, or you can flush it here at the end. And then downstream from the filter, of course, you have your supply. So you can have rigid pipe, polyethylene, or inline. This here is polyethylene. And that's actually what carries the water to the plants. Here's a closer version of what a drip zone is with all these factors that I spoke of. So you have a valve, a filter, and a regulator. This is what a typical residential would look like. This is an anti-siphon valve to a filter to a regulator. Above grade, it's a really nice installation. On this side, this would be more of a commercial way to install in my mind. This is in a valve box. Again, you have the valve, the filter, and the regulator. Each one of these has an important arrow on the side, and that's to install them properly per flow. So the arrow is always pointing downflow, downstream, they call it. So it's very important you check that out, especially if installing yourself. At the end of the tubing or downstream, you'll have what's called an emitter, either built into the tubing or actually plugged into the tubing. But basically what the emitter does is it controls and regulates how fast the water is released. For example, you could have a ½ gallon per hour emitter, and drip irrigation is categorized under gallon per hour, not gallon per minute. It's very important that you know that. The next one would be the flush nozzle, and that always goes at the end of the system. It's very important you flush out, so as you're flushing that filter, you're opening this up, flushing that out as well. It works so well. It just cleans the system out and it keeps everything quite nice, and it's completely worth the time. So everything I spoke about is in a diagram. So if you look on the left here, I'm going to use my arrow. There's the controller leading down to the wiring, the valve, the filter, the regulator, and here's the drip on this side. And that's basically a good description of depiction of what it would look like. Here's a top version, more of a drawing type. You have your zone here, regulator, and then this is actually using inline. So you have your zone 1 here, zone 2 here. So this will give you kind of an idea of what I just spoke about in a drawing. The next thing you need to think about, I guess, is drip applications. So where can we use drip? We pretty much can use drip everywhere, right? But these are where drip, I guess this is the location where drip is used probably the most. And so that's why I'm showing these pictures. But here's a median. And the reason why drip is so important and used in a median is there's no overspray. It's self-contained, and you can still keep it looking nice, low maintenance as well. Obviously, the high desert, we're going to be using drip in the high desert for obvious reasons. There's high wind, high evaporation. Drip is keeping the water near the soil, near the plant, and that's where it needs to stay. So drip is commonly used in the desert, and actually, if you go to most deserts, they're only using drip. And the other thing that I thought was very interesting and very cool is it's being used in hospitals, indoor, and that's been happening for a little while, but what a great application. So plants are therapeutical, as you all know, and we can have plants inside with drip because you don't have the overspray, and it's controlled, and the system can be turned on and you wouldn't even know it because it's so quiet. Okay, so the question is, right, how do I know what type of drip to use? So if you're working in a commercial environment, obviously you need to speak with your client and figure out, okay, what do they envision? What do they want to see? What do they like? What do they not like? And you need to find that out first and foremost. And then also, again, the next step would be the project type. Is it commercial? Is it residential? Is it new or existing? And the new or existing is actually important because if it is existing, there's times where you can use the product, and if it is a retrofit, for example, existing landscape that you're retrofitting, then you can actually convert that over and use some of that base and convert that over to drip. So these are all things to think about. If it is existing, you do want to, I would go to the site and make sure that the product was usable. It's all the newest technology. You might need to replace controllers and such. So all these things are something to think about. The other important factors you'd like to consider is 1, plant spacing, 2, land layout, 3, climate and weather, 4, soil type, and 5, water quality. Plant selection. Okay, so plant selection. I found when working with people that everyone has plants they really enjoy to work with, and I think that's awesome. And usually they do a great job, and is always the case. But when using drip and the plants that you're using, you need to make sure that we're watering to those plants' needs. So I've actually attached a really cool website link here that you guys can all cruise to when you have a second. But it's a great place to go and plug in information. So what type of plant am I using? Is it a 1 gallon, 2 gallon? Is it a shrub? What is it? And it'll actually give you how much water you need for that plant and how long to water. So it's a really helpful, quick tool that does all the calcs for you, the built-in calcs. So that's something to consider. Another thing that's been very, as of recent, is the local law or ordinance change. So where are we placing these plants? And what kind of plants should I be using to conserve water? The next one is it a color or seasonal high maintenance plant? Because if it is, you want to choose a different type of drip irrigation, something that you can move and move back because you kind of want to remove that irrigation out of the way, or it's something that you can plant around. And also the other one opposite is durable and low maintenance. So you're going to want to have a more rugged system in there long term that you're not going to have to maintain as often. So 2 big factors to consider. And then also, sometimes as a designer, a landscape architect or irrigation designer or designer of any sort, you're designing out of the region that you're used to. So if you've never designed in a region, maybe just talk to some people, visit the site, make sure that certain plants that you like are used there, and make sure that the plant will prosper there. It's very important. So in regards to the website that I referred to, there is a general guideline, and I really liked their diagram here, so I used it. The roots of turf grasses, for example, grow 1 foot deep. So I feel like that should say inches, and it should. No, I should say 1 foot, sorry. And then the small shrubs are 1 to 2 feet deep. And then the taproots and the trees of the shrubs. So the larger plants will grow 2 to 3 feet deep. So you have to consider that when watering that plant, how long to water and getting the water through the soil and infiltrating the soil. The other thing to think about is the plant spacing. Do you have a sparse planting, which is on the left, a potted grouped, or a dense? And you could have a variation of all of these. So you could have turf in here, you could have some other things too, but these are the basics to kind of keep you on the right track. So if you have sparse planting, for example, you want to use maybe more of a point source system. If you put a lot of inline in here, you're watering a lot of soil, you're going to create a lot of weeds. So you want to think about that when choosing your drip. Also, obviously with the potted groups, there's different ways to irrigate this with drip. The most clean version is bringing it through the drain pipe and bringing the pipe up and then having your irrigation there. So I see point source, I see inline, micro inline in here. There's different ways to do that. Another way you could do, but has more tubing, is the multi-outlet emitter, but I prefer that you use the first 2 choices. And then of course for the dense, this is a perfect application for inline tubing because you're thinking about watering this area, not necessarily just the roots, but you're watering all of the roots. So you're keeping it in a confined area where there's a lot of roots in one area, and you can control it that way. The other thing to consider is the elevation of your project. Do you have a slope? Do you have loss or gain? So as you guys know, and I'm not going to get into hydraulics, but if you move up a slope, obviously you lose pressure, down you gain. So those are things to consider on plant spacing and layout too, tied in with this on the plants. You want to make sure that some of that water was being shared if you could. So on the downslope, to place that just right. And also when placing the emitters, you should always place it on the upslope of the tree or the well of that plant. Also, something to consider is something that you don't want to maintain if it's not easy to get to. You want to use a more rugged system. If it's If it's not, you just want to have something that you don't have to worry about. So if it was a busy freeway, a median, you'd want to choose a more rugged system. The other thing to consider, obviously, is the climate. Is it really hot, really cold? What's the season? Does the season change? What's the irrigation season? Sometimes it can be really short. And if you're using drip irrigation, you want to make sure that it's a type of system that you can winterize and feel good about using the next season. The soil is a big issue and big concern when designing. So basically you have your sand, loam, and clay. And there's always an intermixture of all of these. And I like this diagram because it shows all the different types of soils that you could get. I wish it was just always loam, but it's not. So we all know this. In regards to how it infiltrates through the soil, this is kind of what it looks like, and it's very important that you know your soil type so you know you're watering. So if you look at the sandy soil here on the left, you can see the water is percolating, infiltrating through the soil very quickly, and it goes straight down. So that means you have to water for a longer period of time in order to get the amount of water to the plant root zone, because it is just surpassing and passing it by. The loam is the best, of course, with the 7-inch depth, and that's what everyone wishes they had for soil. And then the clay is something you have to consider, because what happens is the water, when irrigating with drip, it pools on top, and the water actually can't get through the soil. So the best way to irrigate your plants is to do the cycle and soak. So you might have to run it more than once that day just to get that water to the plant. I would suggest a site analysis of the project or retrieve the reports from your client. Soil amendments might be necessary, because even on one project, you might think you have this type of soil. On the other side of the project, it could be a completely different type of soil. So it's something to take into account. The other issue is, it's not an issue at all, we need water, but we need to look at the water in regards to what we're using. Are we using domestic, potable, non-potable, reclaimed, or well? And lately, I have been seeing a lot more reclaimed and a lot more well. So when using these two types of water sources, you need to consider with drip different things. With reclaimed, of course, manufacturers make a reclaimed version, so you can get product with the purple, designated purple reclaimed color. And also with reclaimed, you need to use a different type of filter. With well water, it's a whole nother animal, because you need a whole filtration system on this guy. But if you're using the domestic potable, non-potable, typical zone in which I showed you earlier will be suffice, and it will work great. So basically the valve, filter, and then the regulator. I would suggest testing the water or having it tested just for documentation for yourself in regards to the project, just so you have it and as backup for yourself in regards to design, to look for some of these items, high salt, calcium, magnesium, and to document it. I think it'd be quite important, because I have seen on different projects where the water quality wasn't what they thought, and of course it affects the system in a negative way. Not only the system if it's poor water quality, but it will actually affect other things such as the housing, fixtures, and so forth. So it's important to test or get those reports on the water. And when testing the water, the two culprits to look for are calcium and magnesium. So again, there's ways to handle these. You can either filtrate, but the chemical treatment is probably going to be your best bet if you have too high of these two minerals. And to get into the chemical treatment and the filtration is a whole nother presentation. But if you are having that, you need to do some research and figure out how to implement that into your system. All right, so we're gonna get into the types of drip. And I think the first and foremost one that's used quite often is what's called inline. A lot of people like to call it drip line. and it's also known as inline. So it all does the same thing. Basically what it is it's polyethylene tubing. And then when it's manufactured, every 12 or 18 inch, the emitter is inserted into the tubing at those distances, preset. So the emitter is actually built in to the tubing. The materials of plastic look and feel, and usually, and most of the time, I would say probably 100% of the time actually, you're using fittings that are barbed, compression, or swivel. So you're not using any solvent with this type of tubing. You're just connecting it with a fitting, typically with a tool or by hand, but there's no solvent used. Some of the actual emitters have a check, which will check up to 10 feet of elevation change. I know that Toro uses the Treflan and Rainbird uses the copper shield to help avoid the root intrusion, and they've been successful with that. So the root intrusion is something to consider when you're using the tubing buried below grade, obviously, because the roots do try to search for water. Point source is the other type. And what point source is it's a combination of emitters, tubing used together. There's different types of emitters. There's single outlet, multi-outlet, threaded, barbed, microspray, and microstream. There are emitters that will check up to, with a little check valve, that will check up to 15 feet elevation change as well. So typically when you see point source, it's combined with the tubing, the pipe. It could be rigid, it could be PVC, it could be flex PVC. There's a lot of different variations to go with it, and I'll show you those in a little bit. But it's very unique and very diverse. And I believe the rule of thumb is that I've always been taught is when the distance between plants is greater than 3 feet on center, you're using point source. So let me go back to the inline because I briefed over it, but typically it's a 17 mil size. And the flow of the actual emitter is 6 or 9 gallons per hour, typically. Some vary. And then again, you're using it with these fittings. So usually when you get the tubing, it's in this roll, and then it's rolled out on the landscape. You cut it to pieces on how you're using it. And then you join it together with these fittings. Point source, these are just different types of emitters. So this is actually a threaded emitter. It's a 1/2 inch thread. So you would thread it onto any 1/2 inch Schedule 40 fitting, riser, or male adapter. And let's see, there's multi-outlet types, and there's threaded. There's single outlet types. So this is a 1/4 inch by 1/4 barb. And then there's also types where you have the 1/4 by diffuser cap, no barb on the type. Here's a different type of threaded emitter. Some have screens, some have check valves built in here, some have the check valves built in here. And there's also streamers and micro sprays. Those are more considered on the bubbler, higher flow side, but those are putting out a spray action, and you guys have all probably seen a bubbler in a tree well. That's putting out quite a bit of water. So that's actually being put out in gallons per minute because the water's coming out so fast on those bubblers. Again, with the emitters, you're using the tubing. So there's 2 different types of tubing. You have polyethylene, which is more of a plastic type of tubing. Typically 700, 600 is what's considered a 1/2 inch. It's a plastic feel, a thinner wall. You're using the press and fittings. The life of this tubing is about 7 years. On the PVC flex or vinyl, you're actually using Schedule 40 fittings, and you are using solvent weld. And this tubing's made in a true 1/2 inch IPS size. So when you're using this tubing, you're using like a 1/2 inch slip fitting, a rigid Schedule 40 fitting. And this life on this, for example, is 30 plus years. So it's a different material, it's a different make. They each have their place in the landscape. It just depends on what your client's looking for, what you're looking for. I'm going to give you some examples of point source on grade. So I feel like most of you have seen this. This is probably one of the easier ways to install drip. But what you have here is, this is the supply tubing, this is the actual emitter, this is the spaghetti tubing, Here's a stake holding it up, and this is what they call a bug cap. So this is just a diffuser cap or bug cap to keep any contamination out. And just different plant layouts, different groupings. This is a good way to use point source, so it's not all even rowed. You can branch off like this with your spaghetti tubing, all on grade, all exposed. Different way here. Here's the different type of emitter where you have the 1/4 inch inlet to the cap, so the water is actually being controlled here, right next to this plant. I believe that's a small tree. And here you can run the tubing and punch the emitter, and like that first diagram I showed you, you actually just run the emitter next to the zone. So this one looks like it's feeding both of these plants. So depending on your plant's requirements, you can choose emitters with different flows. And the flows of the emitters vary, but they are preset typically. So we have them preset. For example, most manufacturers are 1/2, 1, 2, and then it gets larger to 4, 6. But you can choose emitters and figure out the hydraulics and choose that based on your plant's requirements. And so this emitter here could be a larger flow and be watering both of these plants depending on the watering schedule. This is a different example of point source on grade. So this is using a threaded emitter. And basically it's a 1/2 inch thread on grade. So this is a lateral. So this is UVR lateral coming with a flex riser down to the plant. It's all on grade because it's on slope, but it will be covered with mulch. So it will look like this, and this is a 1/2 covered slope, and this is the close-up of what that would look like. So that's a different way to use point source on grade. This is a point source below grade, which is a little different. So now you're burying all the tubing, and you're not on a slope. So it's something that you can do. But here's the rigid system, and then you have a T here, and then you're threading this male adapter in, and here's the riser, and then here's the actual emitter, and this is all you see after it's been buried. Here they're going to do mulch. Here there's some DG. Here's also some older DG. I know there's the color coding for the reclaimed, and then also this is more of a camouflage color that used. There's different colors of emitters that blend in with the landscape a little bit better, so you can choose the brown colors if you don't want to see the black or the standard color-coded emitters for point source. This is for pots or containers, a large pot in a commercial way, so you can see it here being led through the drain pipe and backfilled later, of course, and then this is all you'll see of the actual emitter. So there's one way to do it. The inline on grade is something that you'll see commonly, and I know that most of you see this and maybe want to see it or not. It's so nice to put inline on grade, and it's easy to do, and this is actually a good application because you have a lot of plants rowed and spaced very close together here, and you can see them spaced. So basically the mulch isn't completely over this, but the mulch will cover this and you won't see this irrigation over time. I really do still feel like this type of grid pattern around the tree is probably still the best way to water a tree in regards to drip irrigation. Because as you guys know, in regards to trees, at first the roots are here, but then you always want to irrigate out to the canopy. So even at some point, if possible, there should be another ring added to this. And then if we could all control this, which it doesn't happen, and turn this off. But you always want the tree to stretch and reach to its canopy. So this is I like this picture, and it's a great way to irrigate this tree. Here's another row cropped using on grade. And again, this will all be buried with mulch or rock, depending on your region and what you're using in that region. Below grade, using inline. I always get this question, do you feel like it's a good idea to use inline on below grade? And I say, yeah, in certain applications. So this is some crew here installing it below grade, and you can see it's on a grid system and they're burying it. if you can see this picture here and how the water is connecting, that's good coverage. So this is what you want to imagine if you're going to use inline. The rows actually have to be spaced this close together to get great coverage in order to look like this. So my good friend in the early years, Joe Fertier, designed this, and he was so proud because it was below grade with turf and something really cool. So, and of course, when you're using the systems, you want to think about on the design. Take advantage of what's available in regards to accessories. It's worth the extra money. You want to use the stakes. You want to use, air relief valves. You want to use fittings and all the different components. And the keys to success, one thing that is not considered, but hydrozoning. And hydrozoning is a big deal because all of these plants require different amounts of water, which we spoke about. The trees require a certain amount of water. These shrubs require a certain amount of water. You don't want to put them all on the same zone, as we spoke about earlier. So they'll each have their own zone. They'll each have their own time run and programming. And that's what hydrozoning is you're putting plants that are alike together on one zone. Of course, with the consideration of hydraulics. And if, hydraulics is a whole nother class, but in regards to design of drip and the hydraulic side of it, you want to make sure that you have at least 10 psi at the last emitter, just to ensure that there's going to be water. And then again, it's not always, your client might want to have, to save money, but, you might want to just suggest the highest quality that you can to them because it's your name, basically, on that project, which you guys all know. So it's just something to consider. And higher quality, most of the time, is a higher quality product when we say it is. So as a manufacturer, we'll say this is a high quality product versus, oh, you can use this. And as a manufacturer, we make those suggestions to you. And if you have the choice, the higher quality product will always be your better choice. When working with manufacturers, even on one project, you might be using different manufacturers. So it's good to understand specs of manufacturers as well as how they interact with each other if you want to use them together. Talk to the manufacturers, give them a call. If you can't find it in regards to documentation online, there's always great customer service to help you out with the manufacturers. Things to look at: operating pressure, threads, fittings, are they compatible? Those are the things that I see. The biggest one is different fittings used with different manufacturers in regards to PE tubing, inline tubing. So you always want to check on those things. And then, of course, install drip yourself. You can do it. And I say this because I feel like when you're hands-on with some things like drip irrigation, you will learn the product at a different level. And the awesome things is the irrigation designer, landscape architect, and person working with drip, installing it, have the best ideas. And so we get all our great ideas from you guys. And I feel like if you ask us for, quote, samples, then you can test them at your house or location and see exactly how they work, understand them at a different level, and also, if designing, you can communicate to the installer. So I think it's very much worth the while, and it wouldn't hurt anyone, to be honest. So here's some of the resources that I would suggest checking if you have questions. And then, of course, I borrowed a few photos from a few people, and there's my reference there for that. If you guys have any questions, always contact me. Of course, LandFX can always answer any questions, but you can email me, call me, whatever is easier for you. So thank you guys all very much. It's been a privilege and an honor, so thank you so much.
Thanks, Shelly. We do have a couple of questions in the queue that I'll just ask in the order that they were put through. Firstly, can you elaborate on how the check valve works?
Sure. Okay, so So the check valve and different types of emitters, I guess it depends on whose check valve you're asking about, but I'll just kind of generalize it. I'll start with maybe like an inline check. So the inline check, and what any check does is it holds water back. So when you're charging the system, as it's called, or turning the system on, it takes a second to recharge that system or get the amount of water required to put out the water that the emitter needs to put out and to fill the system. So the check holds that water back and doesn't allow everything to drain out at the lowest head. So emitters have these little checks built in them to basically hold the water back. And so different checks work in different fashions. So for example, the threaded check, I can really talk about that one because I'm familiar with it. But the threaded check, for example, has a spring-loaded stainless steel ball with a spring in there, like a true baby check, and it checks the water back and holds it back upstream from that emitter. So it's holding the water in the line, and that's exactly what it's doing. And then if you have other checks, an inline built in, it's checking to a certain elevation change only. Anything beyond that, it's going to release the water. So that's how it works.
Great, thank you. And I do have another question.
Okay.
How do you really determine when to make inline or point source above or below ground? We know that they can both be laid above ground or below, but how do you really determine which is better?
Okay.
Does it simply come down to cost, or?
Well, it does cost more, obviously, with the labor to install it below grade because now you're trenching and doing that. But if you put product below grade, typically you're hiding it more and you're not going to see the irrigation as well. So there's another reason for it. So if you're wanting to hide the irrigation more and not having to worry about covering it with mulch as often, then below grade, for example, with the inline would be the way to go. So it does cost more, obviously, with labor.
Okay, yeah, I mean, I think that answers. I got another question. What do you do differently with reclaimed water? I would like to assume on the question
okay.
part, maybe it's a project or per context
yes.
situation.
So it's something definitely to look into, the reclaimed filtration systems, but they're their own system of themselves, and they're on the larger scale. You need to filter that water on a larger scale before it even enters into the landscape line. There's systems out there that are available, but even on the downstream of that, we always suggest constant maintenance in regards to checking the filter. You'll still have a filter at a zone on top of that. So that's what I suggest.
Awesome. And I think it probably, we've got a few minutes. I think it'd be a really good opportunity for you to show that resource that you'd mentioned
cool.
earlier in the slides. Yeah, we've got a little bit of time, so let's have a look at that and maybe run us through even an example of, yeah.
Okay. All right. So here's the plant watering guide. And this is something that everyone can use, and it's really cool. If you look at, it's just giving you a general graph here, but if you look at the plant canopy diameter in feet and the trees, it's telling you basically, they basically did all the calcs, but it's giving you an idea of the watering and gallons of water required to wet the root zone. So it's suggesting here in this nice chart, it gives you a good rule of thumb to stick by. And here's this little graphic I stole. The nice thing, and the thing that I wanted to show all of you that I really liked, and that sometimes people don't know because they just never been around drip, but when you look at a 1/2 gallon per hour emitter, a 1 gallon per emitter, a 2, and a 4, this is what the stream will look like. So if you get a 1/2, it's putting out drop, 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 and it gets to be more droplets. And then actually if you get up to the 4 gallon, it's more of a stream. So when people see this, sometimes it makes you nervous because it doesn't look like a lot of water's there, but that's what drip is. It's putting it out slowly and getting it to the root zone, conserving water, but controlled. So it's a good, really diagram of what drip emitters look like. And then in regards to what I was referring to before, if we're using this chart here where you're selecting the plant type, tree, canopy diameter, I don't know, let's just throw a number in here. This is a small one. I don't know, plant description, we don't need to do that. Emitters per plant, I'm gonna say a lot for a tree, so I haven't actually used this, to be honest. I'm gonna say more. So I think it's supposed to calculate for you here. Yeah. So it's saying the valve number 1, trees, the runtime 1 hour. I just did very basic, the tree 4-foot canopy, 4 emitters per tree, because usually a tree would need more. I just said a larger amount of flow. And then it calculates it right here, and it gives you in hours how long to run that. And this is hydraulic calcs all built into this one little chart here, and it's such great information because when going to Cal Poly I took some LIS classes, and the calcs are not that easy to use. They're very difficult. So when you get into design, it's nice to have tools like this. So this pretty much covers it. Again, it goes into the suggested number of emitters for the canopy size, so you could reference this if you were unsure. I just think it's a great place to go. It gives you the different seasons. Yeah, so I think it's a great website. They did a great job. So cheers to you, water, use it wisely. Great job on your website.
Thanks for that little demo. Thanks for that little demo, Shelly. We did actually have another question come through. Okay. Does a 1 GPH emitter tend to clog easier than a 4 GPH emitter?
Not at all, to be honest. It just, in your mind, you feel like it's putting out less water. So unless you're working with an emitter versus a bubbler, then you need to think about what's on the internal of that item. It's a different kind of control element. So in regards to the emitters, no, but in regards to an emitter versus a bubbler, yes. So a bubbler will push through a lot more items than an emitter would, for example.
Okay, yeah, that was a pretty straightforward question. I think you answered that really, really nicely. But yeah, we don't actually have any other questions right now. So okay. I think we can wrap it up.
Okay,
but
thank you all so much.
I think we've, even with a small amount of questions, it kind of speaks really well to the high quality and clarity of the presentation. So I really want to commend you for that, Shelly. Thank you.
Okay.
And if anyone does have any further questions, you can get in touch with Shelly directly. Her contact info is on the screen. But as she mentioned, you can also reach out to us if there's anything specific about, drip in the software. We'll be happy to answer those questions for you. We are, of course, posting this webinar up on our website later this afternoon, so it will be there for anyone who's missed out on attending live, and also you can rewatch and find some of these cool resources if you need to see it again. And just in finishing up, I'd like to thank Shelly for her time not only presenting today, but also the time that she put into putting this presentation together for us, and everyone attending as well. Thank you for making all of these such a fun experience and kind of validating why we like to have guest presenters on board. So thank you, everyone. Just before I let you all go for the weekend, LandFX has an app now, and what you can do through this app is view our power tip videos that cover, the really broad range of topics that we touch on over a yearly basis, I suppose. You can access our weekly newsletters, get important information on updates, upcoming webinars, company info, and much more. And also look at the upcoming events that may or may not be in your area, like trade shows. And you can download this app on the App Store for either your iOS device or Android, and on phone or tablet interface. So have a look at that, download it, give it a try, give us some feedback. But yeah, apart from that, again, thank you, Shelly, and thank you everyone for attending. Have a great weekend.
Thank you.